since we are doing limits, continuity, and differentiability. So today we will do certain questions on limit, continuity, and differentiability, which have been asked in J. All right. Like, see this question. Question number 1. This question was asked in J in 2016. Don't consider if any question is asked in J advanced. So it has to be tough only. Getting my point? At times, questions asked in J advanced, they are reasonably fine also. Now see, they are asking for question number 1. If I talk about limit x approaches to 0, x square sine beta x upon alpha x minus sine x. See, already this question is in 0 by 0 form. Yes or no? So since the question is already in 0 by 0 form, we have to proceed without doing anything. So what is the best I can do? First of all, x approaches to 0, multiply it by beta x and beta x in numerator and denominator both, so that this quantity sine beta x upon beta x, I can make it 1. So it will be beta x cube upon alpha x minus sine x. Fair enough? Now, if you it is still a 0 by 0 form, we are also aware of the indeterminate form. 0 by 0, then we can use L'Hospital rule. So it is limit x approaches to 0, beta. Derivative of the numerator is 3x square. Derivative of the denominator is alpha minus cos x. Got it? Derivative of denominator is alpha minus cos x. Now, again, it should be a 0 by 0 form. At x equal to 0, numerator is still 0. But to make the denominator 0, this alpha minus cos 0 should be 0. Means alpha minus 1 should be 0. So your alpha comes 1. So first point is alpha is 1. Now your question became limit x approaches to 0, 3 beta x square upon 1 minus cos x. If you remember, I have told you, that this is a very frequently used limit. 1 minus cos x upon x square, answer comes half. So x square upon 1 minus cos x, answer will be 2. So this is equals to 6 beta. Am I clear? And this limiting value is given to me as 1. That means 6 beta is 1. In the problem, they are asking for 6 alpha plus 6 beta. 6 alpha will be 6. 6 beta is 1. So answer is 7. I hope this point is quite clear to everybody. It's a simple question. And see, every question asked in J advance is not always a tough question. Got it? Have a look. Absorb it. Now, let's go with the next question. Next question is, let m and n be two positive integers greater than 1. Very good. Limit alpha approaches to 0. Limit alpha approaches to 0. E to the power cos alpha to the power n. E to the power cos alpha to the power n minus e upon alpha to the power m. This is given as e by 2, even minus e by 2. So find the value of m by n, where m and n are two positive integers. Yes. If you would like to give it a small try. Now see, if alpha is 0, this is 0. So this cos 0 is going to be 1. So this is e minus e. That means e minus e. So numerator is getting 0. Denominator is also getting 0. So definitely it is a 0 by 0 form. Am I correct? So what we can do, in limit x approaches to 0, take e common from the numerator. You are left with e to the power cos alpha to the power n minus 1 upon alpha to the power n. Correct? Now, if you see this value at alpha, as alpha approaches to 0, is getting 0. So we will multiply and divide by this. So cos of alpha to the power n minus 1, cos of alpha to the power n minus 1. Now this whole quantity, this e to the power 0 minus 1 upon 0 is getting 1. Got it? So this will become e times limit x approaches to 0. Take minus also common. It will be 1 minus cos alpha to the power n upon alpha to the power n. Correct? Now minus e times 1 minus cos alpha to the power n. So there also I told you that limit x approaches to 0, 1 minus cos x by x square comes half. So whatever is here, square of that is there in the denominator. So I can write it limit x approaches to 0, 1 minus cos alpha to the power n. See, alpha to the power m already here. Divide by alpha to the power n whole square. Multiply also by alpha to the power n whole square. Now this value 1 minus cos x upon x square is going to be 1 by 2. So answer will be minus e by 2 limit alpha approaches to 0. This is alpha, not x. Limit alpha approaches to 0. It is alpha to the power 2n minus n. They are saying this is equals to minus of e by 2. That means this term should not retain here anymore. We got the answer minus e by 2. So if I do not want this term to be here anymore, that means this power 2n minus m should be 0. In the question, they are asking for the ratio of m upon n. So that means m upon n is equals to 2. This is your answer. Got it? Very good question. Simple question asked in a different way. See once. Pallavi, can you switch on your mic? Pallavi, did you get it?
Yes, sir.
Your voice is not audible, beta. Ganesh. Ganesh is asking me to explain it once more. All right. See, Ganesh, up to this point, e to the power cos alpha to the power n minus e upon alpha to the power n. This is the question. They are saying this limit is e by 2. Asking for m by n is what? So what did I do? E to the power cos alpha to the power n minus 1. I took e common from the numerator. So taking e common, e came outside. It is e to the power cos alpha to the power n minus 1 upon alpha to the power n. Now, as x approaches to 0, alpha approaches to 0, this value is getting 0. So if this value is getting 0, I created same in the denominator and multiplied same in the numerator also. So this e to the power 0 minus 1 upon 0 limit, it became 0. Sorry, 1. It became 1. So your question is converted to minus e times limit alpha approaches to 0. Take minus also common. So 1 minus cos alpha to the power n upon alpha to the power n. Then I multiply it and divide by alpha to the power n whole square. Got it? So 1 minus cos 0 upon 0 square. Yeah, 1 minus cos x by x square. Limiting value is 1 by 2. So it came 1 by 2. So it became minus e into 1 by 2 is minus e by 2. And we are left with limit alpha approaches to 0, alpha to the power 2n. And this m came upside 2n minus e. Now, what exactly do I want? That this term should not be here because this is the answer I was looking for. So for this term not to be here, this 2n minus m should be what? 0. So 2n minus m 0. So m by n is getting 2. Got it? Such a very amazing question it is. Now see. Question is limit x approaches to infinite, x square plus x approaches to infinite, x square plus x plus 1 upon x plus 1, x square plus x plus 1 upon x plus 1 minus ax minus b. They are saying it is 4. All right. So how do I do it? See, limit x approaches to infinite. Take LCM first of all. So in the denominator, it is x plus 1. So x square plus x plus 1 minus, I can write it like ax plus b into x plus 1. They are saying this limit is 4. So that is limit x approaches to infinite, x square plus x plus 1 minus ax square minus ax minus bx minus b upon x plus 1. This limit is getting 4. Got it? So this is equals to limit x approaches to infinite. Accumulate in the numerator, it is 1 minus ax square plus 1 minus a minus b into x plus 1 minus b upon x plus 1. This is given as 4. Now see, if the limit is x approaches to infinite, if the degree of numerator will remain more than the degree of denominator, this overall limiting value will go either plus infinite or minus infinite. This is not going to be finite. Got it? Definitely it is an infinite upon infinite form, but infinite upon infinite form is only solvable if degree of numerator is equal to the degree of denominator. Here degree of numerator is greater than degree of denominator. So to make it okay to solve, this second degree term should not retain here. So if this term I want should not retain here, that means 1 minus a should be 0. So a should be 1. Am I clear? A should be 1. So your question became limit x approaches to infinite. If I place a as 1, it is minus bx plus 1 minus b upon x plus 1. This is given as 4. So it is limit x approaches to infinite. Take x common from numerator and denominator. minus b plus 1 minus b upon x, 1 plus 1 by x. Now, as x approaches to infinite, this term is 0, this term is also 0. Your answer is minus b, which is equals to 4. So, implies b is what? Minus. So, your a is 1 and your b is minus 4. A 1, b minus 4. This is the correct answer. See once and absorb it. Very good question. Limit x approaches to infinite. Got it? So, once again, I'll repeat one or two steps. Degree of, while x is infinite, degree of numerator should not be greater than the degree of denominator. If it is so, if degree of numerator is greater than the degree of denominator, answer will be infinite or minus infinite. So here, for the answer to be finite, this term should vanish. For this term to vanish, a should be 1. Got it? Now I place the value of a. You get limit x approaches to infinite. A1 will cancel this, so it is minus bx plus 1 minus b upon x plus 1. Now take x common from numerator and denominator. You are left with minus b plus 1 minus b upon x. X will come out. Here also x will come out and will cancel out. So denominator mein it is x common 1 plus 1 by x. Now this x cancel. Answer is what? Minus b. And they are suggesting answer is minus 4 plus 4. So your b is minus 4. Got it? So good question. Undoubtedly good question. Next. Next here I'll cover a question from differentiability. See, this is the question. Fx is x square mod of cos pi by x if x is non-zero, and it is 0 if x is 0, then f is f continuous, is f differentiable, is f non-differentiable, or whatever it is. Now see, they are asking for differentiability at 0, differentiability at 2. These two things are being asked. Now, first of all, I'll check it at x equal to 0. At x equals to 0. Such kind of question we should always approach using the basic definition, which I taught you yesterday. F dash 0 plus is limit h approaches to 0, f of 0 plus h minus f of 0 upon h. That is limit h approaches to 0. F of 0 plus h will be h square mod of cos pi by h minus f0 0 upon h. This one h will cancel. So it is limit h approaches to 0, h mod of cos pi by h. Yes or no? Now see, this as h approaches to 0, this is cos of infinite. Cos of infinite, I have no idea, but the only thing I know is it's somewhere between 0 to 1 because mod is there. It is somewhere between 0 to 1. Now we are multiplying it with h also. So it is 0 into something minus 1 to 1 or 0 to 1. This answer is going to be 0. Got it? Now let's check for the left hand limit. F dash 0 minus is limit h approaches to 0, f of 0 minus h minus f of 0 upon minus h. That is limit h approaches to 0. F of 0 minus h will be h square cos pi by minus h mod minus f0 0 upon minus h. Again one h will cancel. So it is limit h approaches to 0 minus h cos pi upon h. Mod will absorb the negative sign. Now with this, what can I say? This is also 0 because the cos of infinite lying somewhere between -1 to 1. Mod of this, so between 0 to 1. Got it? So this is, that means LHL and RHL at x equal to 0 is 0. So this function is derivable at x equals to 0. Now, let us talk about the differentiability at x equals to 2. Got it? At x equals to 2. I hope this is clear to everybody. Now, f dash 2 plus, see very carefully. It is limit h approaches to 0, f of 2 plus h minus f of 2 upon h. That is limit h approaches to 0. F of 2 plus h will be 2 plus h whole square mod of cos pi upon 2 plus h minus f of 2. If you see, f of 2 will be cos pi by 2. Cos pi by 2 is 0. So this is 0 upon h. This is what it is. Now, pi upon 2 plus h. This quantity is little less than pi by 2 because denominator is more than 2. So value is less than pi by 2. Less than pi by 2 means first quadrant. So it is positive. So it is limit h approaches to 0. 2 plus h whole square cos pi upon 2 plus h whole divided by h. Got it? Now it is a 0 by 0 form because of cos pi by 2 0. And in the denominator it is h0. So limit h approaches to 0. I will use L hospital ones. So first derivative of second minus of sine pi upon 2 plus h into derivative of this is minus pi upon 2 plus h whole square plus second derivative of first is 2 times 2 plus h and denominator mein derivative is getting 1. Now if you realize this 2 plus h cancel. So as h approaches to 0, this value will be sine pi by 2 minus 1 minus pi. So it overall became plus pi and this is getting 0. So this is pi. In the same manner, you can calculate the right hand derivative. Got it? In the same manner, you can calculate, sorry, this is the right hand derivative. In the same manner, we can calculate the left hand derivative and they will not be same. Am I clear? This is a very good question, undoubtedly bit tough. So answer to this question will be Bombay. It is differentiable at x equal to 0, but not differentiable at x equals to 2. I hope we can do it now. Now see, question number, this one. Question asked in JEE Advanced 2011. It is limit x approaches to 0, 1 plus x ln 1 plus b square whole to the power 1 by x. Now if you see, this is given as 2b sine square theta b more than 0. This is 1 to the power infinite form. Got it? So as x approaches to 0, it is 1 to the power infinite. So 1 to the power infinite form has solution e to the power fx minus 1 into gx. So it will be limit x approaches to 0, x ln of 1 plus b square into 1 by x. This x will cancel. So it will be e to the power ln of 1 plus b square, whose answer is 1 plus b square. Got it? Now what they are saying, this limiting value 1 plus b square is 2b sine theta. That means 2 sine theta is b plus 1 upon b. That means this 2 sine theta can be written as minus under root b minus 1 upon under root b whole square plus 2. Under root b minus 1 upon under root b whole square plus 2. Now see, this perfect square minimum value is 0. So that means this 2 sine theta. And for 2 sine theta, maximum value is 2. So right side minimum value is 2, left side maximum value is 2. So what will happen? Equality will hold. So sine theta equals to 1. Got it? So 2b sine theta then the value of theta is, okay, this is sine square theta. Sine square theta. So sine theta will be plus minus 5. So theta is what? Plus minus 5 by 2. Got it? So this is your answer. Very good question. Simple also. See for a moment. Got it? Now, next question is, let gx, that is x minus 1 to the power n upon log cos to the power m x minus 1. X lying between 0 to 2, m and n are integers and more than 0, and p be the left-hand derivative of x minus 1 mod at x equals to 1. Find the limit x approaches to 1 plus gx equals to p. Then they're asking for the values of m and n. Got it? Now, first of all, what is the value of p? Because they are saying p be the left-hand derivative of mod x minus 1 at x equals to 1. P be the left-hand derivative of mod x minus 1 at x equals to 1. So, if this is 1 comma 0, this is the graph of mod x minus 1. Got it? So mod x minus 1 in the left of 1, what is the slope of this line? Because the tangent is also going to be this line. So what is the slope of this line? This angle is going to be 135 degrees. So that means value of P is minus 1, tan 135 minus 1. So value of P is minus 1. Now they are asking for limit x approaches to 1 plus gx. Gx is x minus 1 to the power m upon log cos to the power m x minus 1. What do? I replace x as 1 plus h. In the right of 1, it is 1 plus h. So we will replace it, limit h approaches to 0, h to the power m upon h to the power n, not m, n. So h to the power n upon m came outside log cos h. Got it? Now, while doing limit chapter, I told you we will limit x approaches to 0, ln secant x by x square, it is half. If you remember, that means limit x approaches to 0, ln cos x upon x square is minus half. So this is going to be limit h approaches to 0. I'm writing it h to the power n minus 2 upon m. I have saved 2h. So h square upon ln cos h. Got it? This value is going to be minus 2. So minus 2 limit h approaches to 0, h to the power n minus 2 upon m. Now they are saying this is equals to p. P was what? Minus 1. Now if this limit is existing and is finite, that means this term should not be here. That means n should be what? 2. Because if this term retain here, then h will retain here and it will make the limit 0. So your answer is what? Minus 2 by n, and I want it to be minus 1. Got it? P. So value of m came. So m is 2 as well as n is 2. Answer is calculate. Got it? So this is your answer. See the question once. It's a very, very amazing question. See it once, guys. Come on, come on. Got it? Now, let's do this question. This is again a very good question once asked in JEE Advanced 2008. Question on derivative. Got it? First of all, let us absorb the info which they are providing. Gx is log fx. Gx is given as log fx, where fx is a twice differentiable positive function on 0 to infinity, such that fx plus 1 is x fx. So what they are saying, that f of x plus 1 is equals to x fx. They are talking about g double dash of something. Got it? See, what is gx? Gx is log fx. So gx plus 1 will be log of f of x plus 1. Am I correct? If I subtract both of them, then gx plus 1 minus gx will be log of f of x plus 1 minus log of fx. Got it? Now I will differentiate it once. So g dash of x plus 1 minus g dash x is, now before doing one, there's one thing we have to catch. It can be written as log f of x plus 1 upon fx. And from this info, fx plus 1 upon fx is given to me as x. So basically, this is equals to log x. Now it is highly simplified. Now gx plus 1 minus gx is basically log x. So g dash of x plus 1 minus g dash x. First derivative will be 1 by x. Then second derivative, g double dash of x plus 1 minus g double dash of x will be minus 1 over x square. Am I clear? Now let us start putting the values of x. They're asking for n plus 1 by 2 minus 1 by 2. So first value of x I'm going to put as 1 by 2. So g double dash of 1 by 2 plus 1 minus g double dash of 1 by 2 will be minus of 4. If you replace x by 1 by 2, it will be minus 4. Now put x as 3 by 2. You get g double dash of 3 by 2 plus 1 minus g double dash of 3 by 2, that is minus of 4 upon 3 square. Now put x as 5 by 2. So g double dash of 5 by 2 plus 1 minus g double dash of 5 by 2, it is minus 4 upon 5 square. And so on. Now see, they're asking for n plus 1 by 2. So last value of x that I should place is n minus 1 by 2. So it will be g double dash of n minus 1 by 2 plus 1 minus g double dash of n minus 1 by 2 is minus 4 upon 2n minus 1 whole square. Got it? Now, whenever you start adding all of them, you realize that they both are cancelled. G double dash 3 by 2 and minus of g double dash 3 by 2. Then they will cancel. Similarly, this will cancel, this will cancel. So what we are left with? We are left with g double dash of n plus 1 by 2 minus g double dash of 1 by 2 is minus 4 times 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on up to 1 upon 2 and minus 1 whole square. Very good question. See once. So the answer to the question is option number answer 1 by 9. 2n plus 1 won't come. So in 2n minus 1 minus 4 times. Yes, A is the correct answer. See once. Got it? Now, let's go. There is a question d2x upon dy square. See, this is something very interesting. d2x upon dy square. They're asking you to write in terms of dy by dx and d2y by dx square. First of all, if this kind of question comes in exam, what best we can do, let us assume fx or y as x cube and then verify the options. Got it? That is very simple. See, if I want to do it using a procedure, this is d by dy of dx upon dy. Dx upon dy, let us assume for the time being that it is a function of y. Because if x is written in terms of y, so dx upon dy will be a function of y. So I can write it d upon dy of 1 upon dy by dx. D upon dy of 1 upon dy by dx. Now, this dy by dx, let us assume it is a function of x. So I can write it d by dx of 1 upon dy by dx into dx upon dy. Now, this is what? The derivative of dy by dx with respect to x. So it is minus 1 upon dy by dx whole square into d2y by dx square into dx upon dy. So finally it is d2y by dx square into dx upon dy whole cube with a negative sign. Got it? So, good question. But the best way, I still recommend you, if this kind of question comes in exam, just assume like y equals to x cube. So x will be what? X will be y to the power 1 by 3. Now, left side you have, right side from the options, you just differentiate. See the correlation and mark it. Got it? Now, see, there is a question. The function is given by y equals to mod x minus 1 mod. They're asking for the points where this function is non-differentiable. So let us talk about a bit transformation of graphs. First of all, there is a function y equals to mod x. So mod x is simply this graph. Now from this, we will draw a graph y equals to mod x minus 1. So drawing this graph means what? Drag the entire graph 1 unit downside. So it will be this. So that this point will become 1, 0. This will become minus 1, 0. Now they are saying from this, what do you want to draw? Mod x minus 1 and mod of this also. Now again taking mod means what? Whatever is there below x-axis, take its impression above x-axis. So the final graph that you have is first this line, then this, and finally this. Got it? Now, if you realize in this W kind of graph, there are 3 sharp corners. 3 sharp corners. One is this, other is this, other is this. Got it? So having three sharp corners means 3 points of non-differentiability. So 3 points of non-differentiability. And the points are x equals to 1, -1, and 0. So these are the 3 points of non-differentiability. Got it? Now, this is another question. Limit x approaches to 0. Limit x approaches to 0. A minus n into nx minus 10x into sine nx upon x squared. They are saying it is 0, where n is a non-zero real number, then a is equal to. A is what they are asking. Got it? Simple question. Let's get it done. Limit x approaches to 0. First of all, divide by nx, multiply by nx, so that I can make it 1. So it is a minus n into nx minus 10x multiplied by n in the numerator. Denominator now it will be x. They are saying it is 0. So it is limit x approaches to 0. A minus n into n minus 10x upon x is 1. Means finally I place the limit. This much into n, it is 0. Got it? So n goes to 0. So a minus n into n equals to 1. So a minus n is 1 by n. So a equals to n plus 1 by. This is your answer. All right. So this is all, guys. I think I have been able to make you understand certain questions, the type of varieties that we see in IIT JEE Advanced exam. See, JEE Mains is not even an easy cup of tea for the last 4 years. They are also asking some of the most tough questions ever. All right. So try and practice as much as you can. Now I